just integrate this function sine cube x cos square x dx. Now, this is an integration that has to do with substitution. It's very simple, but you have to be very careful about it. You don't have to use integration by parts here because it will not work. So what you're going to do is you substitute. Let's say that. Look for the exponent on sine and cos. The exponent on sine is an odd one. That is, it is 3. 3 is an odd number. And from the techniques of integration, if we have exponents on these trigonometric functions and we want to integrate the two of them together at a time, we are going to use our u to be the cos of this. No, the exponent is on sine. The odd exponent 3, which is odd, is on sine. So our u will be cos x. But if the odd exponent is on cos, like for example, if it is a sine squared x, integral cos cube x dx. The exponent is on cos here. That is the odd exponent. 2 is even. We are talking about odd exponent. Since it's on cos here, your u will be sine x. So you understand? But since the exponent, the odd one, odd, is on sine, so your u will be cos x. So in that case now, the u, the x, you differentiate that, will be equal to minus sine x. Okay? And now, if that happens by substitution, let's look at let's substitute. So that means that our dx will be, if you cross multiply, minus du all over sine x. That if you cross multiply here and make the x formula. So this equation now becomes, the whole of this now becomes integral of sine cube x, cos, our cos is u now, that will be u squared, because you say u should be cos x, and this cos square x should be u squared. Our dx now, dx is now what? Is now minus du all over sine x. So which invariably means we can bring out our minus sign and have sine cube x u squared all over sine x. Sine x, we cancel one sine x here. We have what? Minus integral of sine square x u squared. I hope you are following that. I hope you are following that. Beautiful. So if you are following that, that will be very good of us. Now, with this, we may do something. We recall sine square x plus cos square x is equals to 1. So we can replace this by cos equivalence. So that will be sine square x will be 1 minus cos square x. Okay, so this one will now become, this expression will now become minus into 1 minus cos square x u squared. Don't forget the u will be there. Okay, don't forget the u will be there. Okay, so now, and don't forget what our cos x stands for. Okay, so by substitution, our cos is u. So this one will now give us the integral of minus 1 minus u squared du. Because initially we said our u should be cos x. So cos square x will be u squared. So when you expand this now, you have minus into, if you like, you can expand like say u squared, du minus integral over u raised to power 4 du. I hope you understand. Remember, minus is outside entirely. Okay? Our minus is outside. I hope you are getting that now. Okay? So this one will be what? When you open up, you have minus integral. Let's expand. Let's integrate first. This one will be u raised to power 3 all over 3, because you have to add to this one plus 1. Then, don't forget it's outside. Minus u raised to power 5 all over 5. Then plus c. Please, are we following? I hope you are not confused there. Okay. Now, which invariably will mean which invariably will mean that, which is minus u raised to power 3 all over 3 plus u raised to power 5 all over 5 plus c. And what is our u? If you go back to that substitution, minus what? Cos cube x all over 3 plus cos raised to power 5x all over 5 plus c. So with this, we have solved the problem. With this, we have solved the problem. So this is as simple as that. That is integration by substitution. Click on the notification bell so that each time I upload a video, you'll be duly notified. I remain Dr. OJ. Thank you.